Today, flipped lesson number 27A, solving one-step inequalities, day number 2. Yesterday, we learned how to solve one-step inequalities where we had to add or subtract the same number to both sides. In other words, we use the addition property of inequalities or the subtraction property of inequalities. Today, we deal with the other type of one-step problems, the inequalities where we may have to multiply or divide the same number on both sides or to both sides of the inequality. So there's one thing that we have to remember when we're solving one-step inequalities, and what we are doing when we solve them is exactly the same thing that we do with equations, and we talked about that in yesterday's lesson. But there is one difference. And so if we take a look at this inequality right here, 8 is greater than negative 3, that is a true statement. 8 is bigger than negative 3. But if I told you to multiply both sides of that true inequality by negative 2, on the left-hand side we would now have negative 16. On the right-hand side we would now have positive 6. We now have negative 16 is greater than 6. That inequality, however, is not true. So we started with something that was true. This inequality right here was true, but now we have one that is not true. So the question might be, well, how could we make that inequality true? Well, we could make that inequality true if we took the inequality symbol and simply flipped it around. So negative 16 is not greater than 6, but negative 16 is less than 6. So the only way to make the inequality true is to flip it when we multiplied both sides by a negative number. Let's now take a look at a different type of problem. What if we had 8 is greater than negative 6? This is a true statement, much like the last one was. What if I took that true inequality and I divided both sides by negative 2? Now I have negative 4 is greater than 3. Think to yourself for a second whether that is a true statement or not. Of course, this is a false statement. So, much like the last problem, how could I take that and make it true or turn it into a true statement? And the way to do that would be to flip the inequality symbol around. So, while negative 4 was not greater than 3, it is less than 3. So, how can we put all of that together? Well, there's a rule when we are solving any type of inequality, and the rule is this. Whenever you multiply or divide by a negative number, you must flip, or sometimes we can phrase that as reverse, the inequality symbol. So the only time that you will flip or reverse the inequality symbol is, once again, if you multiply or divide by a negative number. Not just multiply, not just divide, multiplying or dividing by a negative number. That's the only time that you will end up flipping or reversing the inequality symbol. So let's start with number 1. I would like you to solve this inequality and graph it. Okay, to solve this inequality, we would divide both sides by positive 5. So my first question in every single one of these is this: did you multiply or divide by a positive or a negative number? And we can see right here that we divided by a positive 5. The only time we flip an inequality symbol is if we multiply or divide by a negative number, and we did not do that. So we finish it off, making sure we made one there. We did the right operation. That's the multiplicative inverse property. And we end up with k is less than 6. The inequality remains the same. We did not multiply or divide by a negative number. To graph this, it should be an open circle over 6 and an arrow to the left. So the solution is k is less than 6. Everybody pause this flipped lesson and try number 2. X over 7 is greater than or equal to negative 8. The operation happening on the left-hand side is division. Therefore, the inverse property to that is to multiply, and we're multiplying by 7. So we multiply both sides by 7. What we are checking for right now is, did we multiply or divide by a positive or a negative number? And the answer to that is we multiplied both sides by that number right there, which is a positive 7. It has nothing to do with that negative 8 sitting right next to the 7. It has to do with what you did to both sides of your inequality. We multiplied both sides by a positive number. Therefore, we do not flip the inequality symbol. The check is making sure that we make 1 there, which is the multiplicative inverse property. 7 over 7 is 1, so we're good there. And we finish this off with x is greater than or equal to negative 56. So the solution is x is greater than or equal to negative 56. Once again, we do not flip the inequality symbol in this problem because we multiplied by a positive number. The graph should be a closed circle over negative 56. We're talking about all the numbers that are greater than or equal to negative 56, which are all over here, and the graph should look like this. All right, everybody pause this flipped lesson and try number 3. Okay, to solve this inequality, we have to divide both sides by positive 2 because that's the inverse property to multiplication by positive 2. The question you should be asking yourself at this point is, did you multiply by a positive or a negative number? And of course, we divided by a positive number. You can see right there, that's what I did to both sides. Since we divided by a positive number, we do not flip the inequality symbol. The check is making sure that we made 1 right there. 2 over 2 is 1. And we end up with a solution of k is less than or equal to negative 5. The graph is a closed circle over 5 with an arrow going to the left. Everybody pause this flipped lesson and try number 4. This problem is r over 3 is less than negative 6. The operation that is happening on the left-hand side is division. Therefore, we need to multiply. And we are going to multiply both sides by a positive 3. We need to ask ourselves this question down here. Did we multiply or divide by a positive number? We, of course, multiplied both sides by a positive 3. Therefore, we do not flip the inequality symbol. The check is making sure that we made 1 right there. 3 over 3 is 1. That's good. Our solution is r is less than negative 18. Remember, we do not flip because we multiplied both sides by a positive number. The graph is closed circle over negative 18. And an arrow, I think I said closed circle, I meant open circle over negative 18, arrow to the left. All right, pause this flipped lesson and try number 5. To solve this inequality, the inverse operation to multiplying by negative 2 is to divide both sides by negative 2. Once again, we are asking ourselves this question: did we multiply or divide by a positive or a negative number? And for the first time, we have divided by a negative number. Anytime you multiply or divide by a negative number, that's when we have to flip the inequality symbol. And we can see right here we are dividing by a negative number. We checked to make sure that we made 1. That's the multiplicative inverse property. We did that. And so our solution is x is less than negative 8. We flipped the inequality symbol because we divided by a negative number. Anytime you multiply or divide by a negative number, you flip the inequality symbol. The solution is x is less than negative 8. The graph, open circle over negative 8, arrow to the left. Everybody pause and try number 6. In this problem, x over negative 5 means the operation happening on the left-hand side right now is division. The inverse property to that is multiplication. So we are going to multiply both sides by negative 5. We are asking ourselves this question right here. Did we multiply or divide by a negative number? Yes, we multiplied both sides by a negative number. Anytime we multiply or divide by a negative number, we flip the inequality symbol. So we made 1 right there. we need to remember to flip the inequality symbol. So the solution is x is greater than or equal to negative 50. Graph, close circle over negative 50, arrow to the right. Pause and try number 7, please. All right, in this problem, we need to divide both sides by a positive 4. Did we multiply or divide by a negative number? The answer to that question is no. Therefore, we do not flip the inequality symbol. Our check is to make sure that we made 1 right there. We did. 4 over 4 is 1. And so our solution is k is less than negative 3. Remember, we do not flip if we multiply or divide by a positive number. Only with a negative number. Do not think that because this number right here is negative, that means to flip. It's what you did to both sides, which we divided both sides by a positive number. So once again, solution is k is less than negative 3. Graph is an open circle over negative 3 and an arrow to the left. Let's go to the next problem. Let's pause this flipped lesson and everybody try both number 8 and number 9. Number 8, we need to divide both sides by a negative 10. Are we flipping the inequality symbol? Think about that to yourself. The answer is yes, because anytime we multiply or divide by a negative number, we flip the inequality symbol. So therefore, the solution is k is greater than 7. Graph is open circle over 7, arrow to the right. Number 9, we need to multiply both sides by negative 8. Do we flip the inequality symbol? The answer is yes. We multiplied or divided by a negative number. That's the only time that we flip. And so the solution is t is less than or equal to negative 16. And the graph is an a closed circle over negative 16 and an arrow to the left. Last problem on our flipped lesson for today is this one. And while this problem is probably the easiest out of all of them, it is one that if we don't discuss it, it will be the most missed one. And the reason is because some people aren't quite sure about what to do with that. Think about that for a second. Is there something that we should change that into to make it a little easier for you? And the answer is we should make that a negative 1n. So let's do that. Now pause the lesson and solve and graph this inequality. Okay, to solve this, we divide both sides by a negative 1. Do we flip the inequality symbol? The answer to that is yes, because we divided by a negative number. Anytime you multiply or divide by a negative number, that's when you flip the inequality symbol. So the solution is n is greater than negative 11, and the graph is an open circle over negative 11 and an arrow to the right. All right, that is it for today's flipped lesson.